we're in chapter 3.3 and we're looking at slope. First objective, compute a line slope. So the change in the y values is the vertical change, or what we call the rise. And the change in the x values is the horizontal change, or what we call the run. We normally use m to denote the slope of the line, and the slope just refers to its steepness. When the slope is positive, the line rises from left to right. And when the slope is negative, it falls from left to right. So it rises from left to right, it looks like this, and falls from left to right, it will look like that. So we know slope to be, using words only, rise over run. So here's a visual representation of the slope. You see the rise is a difference in the y2 and the y1. And then the run is a difference in the x1 and the x2. By formula, slope is equal to y2 minus y1 divided by x2 minus x1. That's your rise over your run. You can remember this order because it's in alphabetical order. Rise comes before run. Therefore, rise is on top and run is on the bottom. And again, they give us the formula. Slope is y2 minus y1 divided by x2 minus x1. Okay, so the different possibilities of slope, we already know slope can be positive, and if it's positive, it's going to rise from left to right. And if it's negative, it's going to fall from left to right. If you have zero slope, then you actually have just a horizontal line. Horizontal lines are written as y equals b, where b is the y-intercept. You see there's no change in y, but I can have many x's, right? So let me pick an example. Let's use this point, and let's pretend like that's a -3. And then let me use this point right here. So the 2 points I have are 0, -3, and 3, -3. Let's calculate the slope and see why does it come out to be 0. So the slope is the difference in the y, so I have -3 minus -3. This is y1 and this will be y2. Divided by the difference in the x's, this is x1 and this is x2. So it'll be written as 0 minus 3. Well, negative and a negative, or minus sign and negative, makes a positive. So what do we get up top? We get 0, and on the bottom we have -3. See, there's no change in your y, so you're always going to cancel them out and get 0 on top, -3 on the bottom. This comes out to be 0, and that's why you have a horizontal line. When you have undefined slope, you have a vertical line. Remember, that's written as x equals a, where a is the x-intercept. So again, let's pick an example and see why. So I'm going to look at the points -5, 0 and -5, 4. And these are just numbers I put on here. I could have called this -4 if I wanted to. And again, let's calculate the slope. So again, it's a difference in your y, so 0 minus 4 divided by -5 minus -5. Since there's no change in my x's, I'm actually going to end up with a 0 in my denominator this time. Since we cannot divide by 0, we call that undefined slope. Okay, so -4 divided by 0, well, that's undefined. And you can see, because there's no change in our x's, we're always going to cancel the x's out, and you get a 0 on the bottom. That makes it a vertical line. So you can have positive slope, negative slope, 0 slope, undefined slope. Alright, so it says find the slope of the line passing through the pair of points and then explain what the slope means. So let me show you a shortcut method for calculating the slope. What you're going to do is write your points and stack them. So it's -7, -8. And then write the other one right underneath it. So 4, -2. Then you're going to see that your commas are lined up. So draw a vertical line down your commas. Extend a little bit out. And then go to the right. Now notice, what do you see up top? -8. And then put a minus, -2. And what about on the bottom? It'll slide and it'll become -7, -4. That's your difference in your y's up top. And that's the difference in your x's on the bottom. And a negative and a positive, negative and a negative make a positive. So that becomes -6 over -11, which is equal to 6 over 11. So we can have slopes that are fractions as well, and this is positive. So we know this rises from the left to the right. So the line rises from the left to the right. Okay, let's calculate slope again. So again, let's write our points, 6, 5, and then 2, 5. Line them up, draw a vertical line down the commas, extend to the right, and now you have 5 minus 5. Make sure you put a minus sign in between. And then you got 6 minus 2. Well, that will become 0 divided by 4, which is 0. So who has 0 slope? Well, notice there is no change in y. Therefore, it has to be a horizontal line. A horizontal line, and it's going to be y equals 5. Okay, so another one. Let's find the slope and indicate if it's a horizontal or a vertical line. So we have the points 1, 6 and 1, 4. Line them up. Draw a vertical line down your commas and then extend to the right. So then we have 6 minus 4 and 1 minus 1. Well, that's 2 divided by 0, which is undefined. Since you cannot divide by 0, we call it undefined. And we notice that there is no change in x. Therefore, this is a vertical line. And it'll be the line x equals 1. Alright, so objective 2, it says use slope to show that lines are parallel. So slope and parallel lines. The first one says, if two non-vertical lines are parallel, then they have the same slope. So if I have two lines, two non-vertical lines, so it could look like this. Well, these go in the same direction. They'll never intersect each other. So slope 1 is equal to slope 2. And it says if two distinct non-vertical lines have the same slope, then they are parallel. Okay, same definition, just backwards. And it says two distinct vertical lines, each with undefined slope, are parallel. So vertical lines are written like this. And we know they're vertical, so we know the slope is undefined. And we know this slope is undefined. Since undefined equals undefined, these lines are actually parallel. More examples. Here we have y equals 2x plus 6, and then we have y equals 2x minus 4. Let's indicate their slopes. So the slope here is the number attached to x, and in both cases it's 2. 2 equals 2, therefore these lines are parallel. Next example, y equals negative 4x plus 5, and y equals negative 4x plus 3. The first slope is negative 4. The second slope is negative 4. Negative 4 equals negative 4, therefore these lines are parallel. It says show that the line passing through points 4, 2 and 6, 6 is parallel to the line passing through 0, -2 and 1, 0. So the first thing we need to do is find the slope of the first line. So I'm going to call it line 1. So how do we do that? We're going to take their points, or its points 4, 2 and 6, 6, stack them, draw a vertical line down the commas, and then extend to the right. You have 2 minus 6, and you have 4 minus 6. And that is -4 over -2, which is 2. And then the second thing we need to do is find the slope of the second line. So again, let's stack our points, 0, -2, and 1, 0. Draw a vertical line down your commas and extend to the right. And we have -2 minus 0, and then 0 minus 1, which is -2 divided by -1, which is 2. 2 equals 2, therefore these lines are parallel. Objective 3 says, use the slope to show that lines are perpendicular. So what does it mean to be perpendicular? Well, if two non-vertical lines are perpendicular, then the product of their slope is -1. We know from geometry that two perpendicular lines form a 90-degree angle. But in algebra, two perpendicular lines, if we multiply their slopes together, so m1 times m2, we will get -1. And then the second one says if the product of the two lines is -1, then the lines are perpendicular. It's just the backwards definition. And then it says a horizontal line having 0 slope is perpendicular to a vertical line having undefined slope. So let's look back at the picture I just drew. This is my vertical line. This is my horizontal line. They are perpendicular. All right, some examples. It says y equals 2x plus 6 and y equals -1/2x minus 4. Well, let's find our slope. So we have 2 here, and then we have -1/2. So 2 times -1/2 is -1. And then for the next example, we have y equals -4x plus 5 and y equals 1/2x plus 3. So here's our -4, and there's our 1/4. So we got -4 times 1/4, and that is -1. Therefore, they are perpendicular. Now notice that if you have the slope of the first line, you can find the slope of the second line by doing the negative reciprocal. The negative reciprocal means flip and change the sign. Flip and change the sign. So 2 is the same as saying 2 over 1. When you flip it, you get 1 over 2, and then it went from positive to now negative. And the same with -4, it's -4 over 1. So you flip it, and you get 1 over 4. It goes from negative to positive. All right, so to show that the line passing through the point -1, 4 and 3, 2 is perpendicular to the line passing through -2, -1 and 2, 7. So the first thing we're going to do is find the slope of line 1. So stack our points, -1, 4 and 3, 2. Draw a vertical line down, extend to the right, and you have 4 minus 2, -1 minus 3. So it becomes 2 over -4, which is -1/2. And then the second thing we need to do is find the slope of line 2. we have -2, -1, and 2, 7. Draw a vertical line down, extend to the right. Let me draw my vertical line again. Extend to the right, and we get -1 minus 7 and -2 minus 2. So it becomes -8 over -4, which is +2. And then the third thing we're going to do is we're going to multiply. So -1/2 times 2 is -1. Their product equals -1, therefore these lines are perpendicular. All right, objective 3, we're going to calculate rate of change in applied situations. Oops. So slope is defined as the ratio of a change in y corresponding to a change in x. Ratio means fraction. So slope is a fraction where it's a change in y divided by the change in x. This is known as the rate of change. So it's basically how fast y is changing with respect to x. Examples of rate of changes or rates would be their speed, miles per hour. How fast are you traveling in 1 hour? Miles per hour. Here's an example. It says use the ordered pairs in the figure shown to find the slope of the line segment that represent men. Express the slope correct to 2 decimal places and describe what it represents. So here's the men's line, and I have 2 points. 2008, 14.7, and 1990, 9.0, or 9.0. So we need to find the slope for these points. So this time I'm going to go ahead and show you the formula instead of the shortcut. If we use the formula, we're going to label our points. Let this be x1, y1, and let this be x2, y2. So then it's y2 minus y1, so we get 14.7 minus 9.0, divided by x2 minus x1, 2008 minus 1990. Calculate, and we get our slope to be approximately 0.32. So then it says the number of men living alone increased at a rate of 0.32 per year. Since x is in years, this is per year. Just like the example of miles per hour. For 1 hour, how far can you travel? This problem says how many men live alone per year. Well, it increases at a rate of 0.32 per year. So the rate of change is 0.32 million men per year live alone. Okay, so this will conclude our video for 3.3. Please email me if you have any questions.